Hello viewers, tutorial 4 question 1, and we have a system of equations to solve. So we have two equations, we also have two unknowns. X and Y represent some numbers that both in combination make the two equations true. So do we go about solving this system by elimination or by substitution? Looking at that first equation now, we see that it is already solved for y. It's already y equals something. So that is set up for substitution. Okay, so we'll substitute equation 1 into equation 2. So that second equation becomes 2x minus 3 times y. Well, the first equation tells us y is x plus 3, so that becomes x plus 3 equals 2. Now let's multiply that 3 into the bracket, so we get 2x minus 3x minus 9 equals 2, and therefore we can move the 9 to the other side of the equation, so that gives you negative x equals 11, which means that x must be negative 11 if we divide both sides of that equation by negative 1. So we get x equals negative 11. Okay, so if x equals negative 11, what does that make y? Because we're not finished yet, we've got to find both letters. At the moment, we only have the value of x. So from the first equation, so from equation 1, we can say that y equals x plus 3. X is negative 11 plus 3 gives us negative 8. So the solution is negative 11 comma negative 8. Now we should check that. So if we substitute that into equation 2, don't use equation 1 because we've already used that to find what y was. So if we use equation 2, we've got 2 times negative 11, which is negative 22, minus 3 times negative 8, which is 24, so we've got minus 22, plus 24, which is indeed positive 2. Okay, so question B, we have another system of equations. We have x plus 4y equals 9, and we have 3x minus y equals 1. So we need to work out what approach we're going to take here. Elimination or substitution? Well, a case can be built either way here. It's already set up in the form that we've got x's and y's on one side and numbers on the other in both equations. But on the other hand, it's not too difficult to solve that first equation through for x, so we'll do that. So if we solve that first equation for x, we get x equals 9 minus 4y, and we'll substitute that into equation 2, into the other equation. So that becomes 3 times x. Well, x is, we've just found to be 9 minus 4y, and that minus y, so we're putting it into equation 2, equals 1. So let's multiply the 3 into the bracket. So we get 27 minus 3 times 4 is 12y. Then we get minus y equals 1. So if we rearrange the equation so that we've got all of the terms with a y in them on one side, everything else, so the numbers to the other side, we've got the y term is going to be minus 13 times y equals, and we're going to subtract the 27 from both sides, so that gives you negative 26. So we have our value of y almost. If we divide that through by negative 13, we get y equals 2, and we'll substitute into our rearrangement for x, which is 9 minus 4y. So we get x is 9 minus 4 multiplied by y is, we just found that to be 2. 9 minus 4 times 2 is 9 minus 8, which is 1. So your solution is xy, x first, which was 1, and y was 2. So let's check that by substituting into the other equation, into 3x minus y. So 3x minus y is 3 times 1 minus 2, which is 3 minus 2, and we do indeed get 1 there, which is good. Okay, so let's look at question C, which is a third system of equations. So we've got 5x minus 6y equals 0, and we've got 2x minus 5y equals minus 13. So should we use elimination or should we use substitution here? Well, it's not so easy to solve either equation for x or for y without introducing fractions. So it might be better to do elimination here. So we'll eliminate y from both equations, and the way we're going to do that is the multiplier of y in the first equation is 6. So that means we'll multiply that second equation, whole equation, through by 6. And the multiplier of y in the second equation is 5. So we'll multiply that first equation by 5. So if we multiply the first equation through by 5, what do we get? We get 25x minus 6 times 5 is 30y equals 0. And we also need to multiply that second equation through by 6. So we have 2 times 6 is 12x minus 5 times 6 is 30y equals minus 13 times 6 is minus 78. So you can see why we did that step of multiplying one equation through by 6, the other through by 5. It gave us a 30y, so the same number in front of y in both equations. So now we need to eliminate y completely. Do we add them or do we subtract them? Well, negative 30y minus negative 30y gives us 0, and 0 is what we're looking for because that means our y will be cancelled out. So we said minus there, which means we're subtracting the two equations. If the two y terms, which is what we're trying to eliminate, have the same sign, then we will minus the two equations from each other. So 25x minus 12x gives you 13x minus 30y minus negative 30y is 0, which is good because we don't want any y's appearing in the equation. In a system of equations, if you're trying to solve it by elimination or substitution, the goal is the same, to reduce the two equations down to one equation with only one letter. So here we're heading towards one equation with only an x in it. So right hand side, got to do the subtraction as well. 0 minus negative 78 is positive 78, and we can divide both sides through by 13, so that gives us x equals 6. And we'll substitute that into 5x minus 6y equals 0. So x was 6, so we've got 5 times 6 minus 6y equals 0. So 5 times 6, what's 5 times 6? That's 30 minus 6y equals 0. So if we move 6y to the other side, we get 6y equals 30, and therefore y equals 5. So our solution here is xy equals x was 6 and y was 5. Let's check that with the second original equation. 2x minus 5y equals negative 13, hopefully. So 2 times x is 2 times 6 is 12. 5 times y is 5 times 5 is 25. 12 minus 25 is negative 13, which, that checks out. So good as gold. Thanks for watching. Over and out.